Dr. Winters. It is Mary here, and I am doing my article debrief 1, and it is on Never Say Anything a Kid Can Say by Stephen C. Reinhardt. Just to sum it up, he didn't think his methods of teaching, the traditional teaching route, was effective. He didn't feel like his teaching was constructing a long-term impact upon his students, so he decided that he needed to change. He felt like he was teaching and he felt like he was doing good, but at the end of his teaching, he didn't feel like his students were learning anything from it. He decided that if his students were to ever learn mathematics, that he needed to take a step back and he needed to be the listener while his students did the explaining and the talking. One of the key points that stood out to me was allowing students time to process questions. Wait time is very important. So this is really important. I feel like, and just working in the classroom, I've seen this happen. Giving the students wait time, this allows students to use higher level thinking when answering their questions, and it gives them time to wait for a second and figure out what they're going to say. I feel like if you incorporate wait time into your classroom, you'll have fewer I don't knows, or more, you just have more elaborate answers and or questions from your students after your lesson. One of my other key points was be non-judgmental about a response or a comment. I feel like this is very important in classrooms, because instead of saying, "Oh, you're right," or "That's awesome, you did wonderful," or "No, that's wrong, you're wrong," teachers should try to say things like, and more encouraging things like, "Thanks for trying that," or "That's interesting, can you tell us more about that?" And not to just shut them down immediately or be too dramatic with their responses. If one student has a better answer and the teacher praises them so much how great of an answer that they had, the next student that comes up to answer that question is going to be hesitant to give an answer, because if their answer was great, then they don't know if their answer is going to be that great. Or if the teacher immediately shut them down and was like, "That's wrong," or gave them a negative impact upon their answer, I don't know about anybody else, but even I would feel like I'm going to get a negative impact if they got a negative impact. I just feel like that discourages your children, so you won't get any feedback for them. They won't talk to you. Another one of my key points was do not allow students to blurt out. I know this is really hard, being in a classroom. Some kids, I know a lot of kids with ADHD sometimes can't help blurting out. But with time and practice and being patient, we got to stop the blurting out of the kids. It defeats the purpose of wait time if we have kids that are blurting out. Because once that one kid blurts out, the rest of the class stops thinking. They're like, okay, I don't need to think anymore because he's already said the answer. If it's right or if it's wrong, I don't need to think anymore. So if you give those students that 10-second, 15-second wait time, it gets their thinking into high thinking. So I do feel like it works. Also, having other kids blurt out is not fair to other students because they didn't get time to explain their thinking or whatever. This is my article debrief number 2, reading 13 Rules That Expire by Karen S. Karp. Sarah B. Bush, and Barbara J. Daughtry. So this article focused on getting teachers to stray away from easy, quote unquote, easy tricks when teaching students math. The tricks or repeated practices help students in the time that they're learning, but down the line it frustrates and discourages students from math. So, one key point that I got out of this is the always rule. This quote on the second page, students later found that these rules are not always true. In fact, these rules expire. Such experience can be frustrating, and in students' minds can further the notion that mathematics is a mystery series of tricks and tips to memorize rather than big concepts that relate to one another. So I found this definitely true. I feel like I didn't have teachers to tell me that these rules expired and or do not work anymore. So it was frustrating doing math and solving, quote unquote, solving the problems how I was taught, and it was being incorrect and the teacher not assisting in helping assist me solve the problems, or telling me that these rules have expired or these rules never work, don't work anymore on these type of problems. So that was one thing. Another key point that I had, you cannot take a bigger number from a smaller number. Later, when students encounter applications or words, problems involving contexts that include integers, they learn that this rule is not true for all problems. So it's just like taking a positive from a negative, if that makes sense. So taking a lower positive from negative. So you have that negative number. You can take smaller numbers from, you can take bigger numbers from a smaller number. My third key point was that it says multiply everything inside the parentheses by the outside number of the parentheses. So this is not true. This is true only when numbers or variables inside the parentheses are being added or subtracted, because the distributive property is being used. This rule is untrue when multiplication or division occurs inside the parentheses. This actually expires in grade 5, i.e. when I started having trouble with math. So hey, Dr. Wayne, it's Mary Dobbs again. This time I'm doing an article debrief on Unpacking Word Problems for Diverse Learners, a Guide to Using Schemas by Elizabeth A. Stevens and Sarah R. Powell. So this article was about the challenges related to word problems for diverse learners. So one of the key points that I pulled out of this was on the first page, and it said, research indicates that students with disabilities perform lower in math than peers without disabilities. And this is especially true when solving word problems. I feel like this is true. Just working in the classroom, you see a lot of the children with disabilities. Their math was their low level, or they had math intervention. They had to get pulled out for math because they struggled in math. Why would be a good question. Why not reading, or why not a different area that they struggle in? Why so much math? What is it that they're struggling in math that's causing them to perform so much lower than their other peers in the classroom? A second key point that I saw was on the same page under problem solving challenges. Word problem challenges. So word Problem solving requires students to engage in a complex process of unpacking the problem. In a given word problem, students must be able to do the following: 1. Read the problem. 2. Identify important versus extraneous information. 3. Identify the unknown information to be solved. 4. Choose a strategy appropriate for the problem type. 5. Solve the problem correctly. Furthermore, students often are asked to retrieve information from tables or graphs, require competence in interpreting data. Students may have difficulty with some or all of these steps. This is interesting because I feel like this doesn't just connect with students with disabilities or diverse learners. I feel like this kind of goes out to all children who possibly struggle in math. This is a lot. A lot goes into solving word problems. So this kind of breaks it down, and you actually see that it is a lot. So unfortunately for students without disabilities, solving word problems can also be difficult. So I think altogether is, how can we help all children learn how to solve word problems? So yeah, this hits on diverse learners, but I also think that it kind of coincides and helps with general education students as well in the classroom. So a third point that I had was actually on this in the same paragraph. Students must approach word problems flexibly. There are various problem types and no one size fits all strategy. Therefore, students must engage in a critical and dynamic approach to problem solving each time they encounter a new problem. So, I really like this quote because I feel like because yes, a student must be flexible. They must, because not every child learns the same. So every child is different. So not one strategy will work for every single child. So not one strategy fits every single thing. Just like how when a teacher is teaching, just not one strategy or way that you teach fits every single child. You have to adapt your teaching style. So you have to change strategies to figure out which strategy works for you. Hello, this is my article debrief for my fourth article, 10 practical tips for making fractions come alive and make sense, by Doug, Ann, and Annie. All three of those were researchers in Australia who produced this article. One of my key points that I pulled out of the article was on page 379, and it was under number 3. Emphasize that fractions are numbers, making extensive use of number lines in representing fractions and decimals. I feel like using a number line for fractions has several advantages and is really helpful for teaching fractions and also for students just doing fractions on a daily basis. Having that number line, it helps them see the whole numbers, the fractions, and the decimals, how they can all relate. In the article, it says it provides a way for understanding why 5/3 is the same as 1 whole and 2/3, and 6/3 is the same as 2. It makes it easier for students to understand the notion of density of the rational numbers. I think this is how I learned how to do fractions, and although it works, I feel like at some point in time it does go away and you have to find another strategy to use. But starting off on fractions, I do feel like the number line works really well. A second key point, provide a variety of models to represent fractions. So I do feel like teachers should use different kinds of manipulatives. So besides the number line, you should have manipulatives such as fraction bars or rods or paper folding or laminated shapes, or even going as far as is incorporating technology and using computer programs to help show fractions. I think that is very important. But students also need to be familiar with those different kinds of manipulatives before they go ahead and get started into them. I believe that when students share their strategies for comparing fractions during class, other students may be convinced to use both benchmarking and residual thinking to tackle relative size and ordering problems. I don't know, that quote just stood out to me. I felt like it was an important part of the article. Who knows? Maybe not. Hello guys, it is my article debrief for my final article. The article's title is A Mathematical Cornucopia of Pumpkins by Glenn Gebhardt. So this article discusses the investigations in a classroom with tasks that incorporate mathematical skills and science skills. Key point 1. It said that students should know how to use a ruler and centimeter tape to measure their pumpkin's length, diameter, height, and circumference to the nearest centimeter. I thought this was important because most of the investigation and most of this project had to do with measuring and using the circumference of the pumpkin and just stuff like that. So it is important for a teacher to make sure that they do like a prior knowledge to see what they know, prior knowledge check to see what they know about ruler, centimeter tape, measuring circumference before they do this activity, or that could be a hold up within the entire assignment if they don't get that accomplished first. So if they don't know how to do it, then it's a hold up for the assignment. Key point 2, for all activities we begin with real world models, something that can be manipulated. I thought that this was important because I feel like when you do hands-on activities, that's the purpose of you having real world models. So like something that you can actually touch and feel and manipulate and play with. And you also want something that's going to intrigue the students. So I probably can't come up there and say that I'm going to come with a fake pumpkin. They're probably not going to be as excited if I say we're going to do a project with pumpkins, real pumpkins. I just think the real is more intriguing than a fake pumpkin. And it's just more fun. It just brings the funness to science because a lot of times we don't get to do science. Key point number 3, discussion of the interesting questions is an important ongoing part of the investigation. Most students that generate questions are simple measurement questions. Most questions that students generate are simple measurement questions. I do feel like the interesting, quote unquote, interesting questions are good for students because this gives the students time to jump into that or tag into that higher level thinking and skill, and they want to answer questions using higher level thinking. And I like how the teacher is continually throughout the entire process of this investigation asking those questions, and once they finish one step or they think that they're finished with one step, they'll go up to the teacher and she'll ask them another question that gets them thinking. They have to go back and think about that question, or when they answer that question they have to measure it and remeasure it and stuff like that. So it gets them doing more things, more ideas to do with the pumpkin and stuff like that. I just loved how she did that from the start to the finish. She continually asks those higher level thinking questions to the students to get their brains engaged. Overall, I think this was a great article. I really enjoyed reading the strategies for asking good questions. They were really good strategies to read about, and they're really good to use in my future classroom, and he gave great examples. This article showed me how possible it is to have student-centered classrooms and how they work and how to incorporate wait time and stuff like that. Yeah, this was a good article. I really enjoyed reading it. Thanks. Overall, this article, teachers need to be aware of what they are saying when they are teaching. It will confuse the kids in the future. Teachers should focus not on mathematical content, but more so mathematical practices to show that it's not just memorization. It is a concept for this and a reason that we are doing it. A question that I have is, what resources are giving and or available to educators to help them better understand and better implement conceptual math? So this was, I think this was a good article. It really helped me understand the different math practices and these rules. Some of these rules, I felt like I knew. This is what I use. So now knowing that they don't work after certain grade levels, most of them were 5th, 6th, 7th grade. So I'm glad that I learned that. So now that I know better when doing my math and also when teaching math, and I have to know that sometimes this can get really difficult and messy, but it's okay, and you just got to keep pushing. I have this article to refer back to. It gives you different examples to use and stuff, so I like that. Yeah, this is just it was a really great art. It was a good read to read and to learn about all those things. Overall, this was a really good article. This was a great insight on how to help students with disabilities work word problems, but also for students in general, because word problems can be tricky to solve. So I do feel like they gave us a lot of good things like charts in the article to help us. So this is a really good article. Overall, this article really made me feel better about not liking fractions, not wanting to teach fractions, because I guess I can say that I feel like I wasn't the only one after reading this article. Fractions are hard to teach, fractions are hard to understand, and fractions are hard to learn. Like I said, they're really hard for the teacher and the student. But this article is really helpful, and it gives us the 10 tips that help us work with fractions and help teach fractions and examples. And in the back, I really liked it. Also gave us a worksheet on how to do fractions, an activity sheet on fractions, and I thought that was really fun and exciting. We can do that and actually incorporate it into a classroom as well. So, yeah. I like that it was so detailed. So if you wanted to do this in your classroom, you could do it. And they also attached a chart, a data chart for you to do. So I thought that was fun. And they have other diagrams and figures that show the kids doing it and just some of their data that they collected